3D Printing Today, show number 423, Pellet Extruders, Enraged Rabbit Material Switcher, fixing the massively non-manifold.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it doesn't matter, we cover it all. My name's Andy Cohen, and I'm here at Mr. Whitney Potter.
How you doing, Andy?
I'm doing pretty good. But the folks in the Baltics are not.
Yeah.
And I didn't think we would have a news story this quickly, but we do. And it's not your typical, this person made something that looks like a Ukrainian flag. No, this is actually highly relevant to our typical stories in our show about 3D printing companies and investment. There's a company called Zortrax. Now, Zortrax is in Poland, a very well-known 3D printing manufacturer, high-quality 3D printers. I've played with one a while ago. It's been a while since I've seen one, but they're usually well-regarded by their owners. I've never really heard a lot of bad things about Zortraxes. In any case, Zortrax has refused a rather significant investment from Russian investors.
Yeah, it's $65 million. Basically, a Russian company was trying to buy a substantial portion of Zortrax for $65 million. And Zortrax said, "No thanks, boys. Keep your money. We don't want anything to do with you."
Now, I got to say that the folks at Zortrax, they've got a lot of, I wouldn't say chutzpah. I think they're being very moral and good, and they're doing what they believe is right. Now, if it were me, I'm not that morally refined, and I would have said, "Yeah, sure, give me your money."
Give me your money, and then I'll take it.
Then I would have told them to go to heck.
Right.
Anyway.
Well, that's a little bit more difficult to do these days, and actually even getting the money would be difficult at this point,
problem.
Given the status of Russia in the international banking sphere right now.
Yeah.
So.
In any case, we wish Zortrax well, and we hope that they continue and are successful with their latest products. In the meantime, what's coming up on our show this week, Whitney?
Let's see. We start out talking about pellet extruders.
And then we discuss the Enraged Rabbit Material Switcher, kind of like an MMU clone.
There you go. And then we contemplate fixing the massively non-manifold.
Let's do it. So the last time I went to Murph, and by the way, now's the time to start thinking if you're going to go to the Midwest Rep Festival, now's probably the time to start planning it. I'm probably not going to go. I'm sorry. It was a wonderful thing to go to, but I'm going to limit my travel, and that was a little bit of an excessive travel. Mm-hmm. Maybe next time, or maybe East Coast. We're going to think about it. But the last time I went, See Me CNC was there, and they had this giant Delta printer, and this thing was huge. It was a monster. It was so big that the extruder's hot end, the opening was fairly large, and there's no filament that you could use for that. Mm-hmm. And what they did was they brought raw pellets, and the raw pellets were sucked up with a vacuum and drawn into what looked like an auger-based system. Mm-hmm.
Yeah.
And it was very impressive. So basically they went from pellet material directly to extrusion.
Yeah, and that actually makes a lot of sense. I've been looking at pellet extruders as a concept for plastic, recycling. Because we've talked before about how it's very difficult to chip up old prints, and then create new filament from them. But conceptually, it should be easier to chip up old prints and print them directly with a pellet extruder. So I've been kind of looking into the world of pellet extruders. It makes a lot of sense that CME CNC would be doing that, because you remember what CME CNC did, or rather what their parent company still does. They're an injection molding company.
That's right.
So they're certainly have all of that technology, and probably just take old injection molding screws that were worn out or not good for that, and make a pellet extruder from them.
Yeah.
So there have been a number of attempts over the years of different people to make different make pellet extruders, and you can see that it's still kind of a wide open playing field. There are solutions that you can buy. Like there's one that they sell it as an add-on to your 3D printer, whatever 3D printer you want. It has to be quite large, because this thing is like 16 or 18 inches long, as most pellet extruders tend to be larger.
I think I would have thought it'd be bigger than that. I mean, think about it. The pellet extruder needs a way of transporting the pellets into the augering system, the crushing system. And that auger or drill bit or whatever you're using, that's big. It's got to be in containment that can handle the pressure. It's got to have a motor that's got the torque and the strength to rotate and crush the filament while it's getting soft and blend it properly. That's a bit of a tall order for a desktop 3D printer.
Well, there are solutions on all different sizes and scales. There's one of them that they're asking $10,000 for just the hot end. That's out of Canada. There's another one that's from Spain that's like $400 or $500. I'm personally looking for an open source version of it. The big sort of differentiator in these systems is the screw, and how what are you using as a screw? Back in the old days, people were using like a ship auger drill bit, which works, but it's not ideal because it has a uniform cross section the whole length of it. So your ideal system, how deep the screw is cut, it gets shallower as you get towards the tip, so it increases the pressure as the material melts. Is sort of the idea.
Interesting.
And you'll see that's ubiquitous in injection molding screws and that sort of thing. And now China has caught up, and there are Chinese companies that are actually producing and selling relatively small, relatively inexpensive, like a couple $100 instead of a couple $1,000 injection molding type screws designed to be used in plastic extruders. So we may be getting to the point where it can be done. I have yet to see an open source project that has really brought all the pieces together. Everything right now seems to be commercial, which is fine. That kind of makes sense. It's a fair amount of work involved in developing these things, but with the advent of the cheap Chinese screws, and it comes with a barrel that matches it perfectly, and the heaters are relatively easy to obtain. It's not that hard to put the system together now. Yeah, so,
as long as you can get the shipment out from China.
Well, that's true. Yeah, you have to get the parts.
We're going to do this in a different segment, but I think assuming the assumptions we used to make about getting things super less expensive from overseas producers, that may be coming to an end.
It may be.
So, a post from one of our members on our Google group, whose handle is John Day. That's probably his name, and he had the consideration to put a photograph on there. So, thank you, John. John posted some pictures of products that he makes using the MMU2. And I got to say, these are cool. He uses them in his business. They're really, really well done prints, really beautiful stuff. And he's getting some great stuff out of the MMU2. And he mentioned to me something that I do want to mention. We kind of describe the MMU2 as it basically cuts the tip of the filament off. And John wanted us to clarify basically that it only does that when it senses it can't feed the filament back out. And when it does pull the filament out, it kind of jerks it around within the PTFE tube to kind of shape it, kind of similar to the chameleon, the 3D chameleon
process in the chameleon.
But it doesn't depend upon it when things don't work well. It senses it, I guess, in the feeder motor and pulls it all the way back out, cuts it, and then goes all the way back in.
Oh, that's cool.
But I wanted to talk about the MMU. You know, the MMU, especially MMU2, is getting quite a bit of usage. There's quite a bit of samples out there. People are using it successfully. I know from other people that it's not that easy to use, not that any multi-material solution is easy to use. None of these are toaster-like. There's complications in slicing, complications in the mechanisms involved. These are very advanced forms of open source 3D printing. But the MMU2 is really not, well, I think it is. I think the MMU2 is open source. But in that vein, we wanted to talk about a form of material switcher like the MMU, which is fully open sourced. And its name is the Enraged Rabbit. And
formerly, it's the Enraged Rabbit Carrot Feeder.
Yes, and it's an impressive hunk of plastic and metal. There's quite a bit there. And we have the GitHub on our reference notes. If you're interested, or you could just Google Enraged Rabbit Filament Feeder, and you'll find it. It also includes the carrot patch, which is basically managing your spools and the feeding into the feeder.
Rewinds the filament after you eject it from the printer, so it doesn't get all messed up and tangled.
Yeah, which is easy to do, by the way. Again, so what these devices do is they automatically unload and then reload filament. That's basically all they do. They don't need the extreme complication of splicing the filament, but there's a difference, an extreme difference in that when you splice the filament the way the Mosaic products work with the pallets, the filament is continually going through the same nozzle. So when you switch filaments, you have to prime all the old material out and then prime some of the new material. Whereas the MMU, you take the material completely out of the hot end and put new material in, and the new material must flow all the way through and be primed that way. Both of those are significant disadvantages when you compare it to a tool changer. Whereas a tool changer, you're using different nozzles, and you can prime the nozzles off-site without having to build a huge purge block.
Right, you don't have to purge them at all because you've got the same material in them every time.
You want to prime them, but you don't have to purge them. You want to prime them, and you want to clean the tip. And you still need to do those same things with one of these other devices.
Sure, but you also have to purge the old color.
Right. So if you're interested in trying an open source MMU, the Enraged Rabbit, which I believe is currently mostly focused on Clipper usage, although they do talk that rep firmware is possible, and the GitHub kind of also focused on using it with the Voron, which is fascinating. It really is an interesting solution, a Voron with a working MMU-like device. Sounds
I think fun. That's kind of the focus of the project, and that's ete-git is the username. I'm assuming that the git refers to GitHub, but ete is the individual's name from France. Is the person who seems to be driving the project. So
anyway, so there are open source versions of filament switchers out there. And this one, you can buy all of the non-printable parts as a kit for a bit over $100 on AliExpress. You know, all the motors and all the couplings and parts and stuff. And there's a little board that you do have to buy. A little bit of smarts in there that are needed, just like the MMU that has one. And that controls the the feeder motor and the switcher motor. There's 2 steppers in there. And it does look kind of complicated. We're not going to take one of these on. We got other things to do, but I'm sure others out there will, and maybe they'll post on our forum.
Although it would be cool to have one because, since it's the Enraged Rabbit, every time your printer screws up, you could talk to it like Elmer Fudd. You could be like, I'm going to get you, you wascally wabbit.
Well, there's motivation for you. There you go. Whitney, build a Voron and put an Enraged Rabbit on it. And then you can talk funny to it.
Just so I can talk funny to it.
And you can talk funny to it. And your wife will come out going, oh, man, this guy's getting weird. Not that you're not weird.
Weirder. Yeah.
Weirder.
Yeah. So we have a question from listener Jamie Ding. He says he has a model of a few city blocks ripped from Google Earth that he wants to print in full color and get printed on an HP Multijet or something. The problem is it's extremely non-manifold. That is to say, there's probably all the individual buildings are not manifold, and they're probably not attached to the ground. I don't know the exact procedure from ripping from Google Earth, but I used Blender's GIS toolkit to do a similar model and just sort of see kind of what some of the problems would be. And at least on my version, I imagine it's probably similar with Google Earth. The problem is that the buildings are coming from one data set and the ground is coming from another data set. And because of those two, there are errors and inaccuracies between where the bottoms of the building meet the ground, and they don't even try to fix those. So you end up with, at least on the Blender version of it, you end up with each building being separate objects, and each building being non-manifold objects, and that the bottoms of the buildings don't exist. They're just open on the bottom. And not only that, but they do not meet the ground. They just sort of float, somewhere relatively close to the ground, sometimes a little bit above it, sometimes a little bit below it, but just basically right there. So in terms of all of the sort of standard tricks for how to get those to join, pretty difficult. The one that comes to mind would be to take the surface, right, extrude the ground surface into a manifold 3D object, and then Boolean the other objects onto it. But the problem is if the other objects, the buildings don't intersect that surface, which they don't reliably, then that's not going to work.
Well, let me give you my take on it. I would start with, first of all, you have to do it in chunks. You can't do the full thing. And then you have to zoom in. So they have to be larger because you have to be able to see the mistakes and the problems in the mesh.
Right.
So you're going to do large chunks. You're going to enlarge it and chop it up into chunks. And then each chunk, you're going to have to treat the separate objects as separate objects. And take those separate objects and be ultra careful not to change their location, and read them into a program or utility which will fix them and retain their locations and then put them back. So those tools
fix the buildings,
and the land underneath, and to do separately, because I don't know any other way to do it. And to do that, there's a couple ways. One way we've talked about on the show quite a bit. If it's not too much of a mess,
right,
you can import it into 3D Coat and then remap it as voxels and then export it as a completely remapped object. Another way is to use Fusion 360 and remap in Fusion 360 with a different type of mesh style. Both of those have extreme limitations in how many faces you get in your facets. So whatever you do, you can't have extreme resolution on any tool. So no matter what this is, you're going to have to decimate the faces down a little bit so the tools can handle it. So, if you're going to take this big chunk of a map and expect to be able to do anything with it, that's kind of asking the software to do a little bit too much, I think.
Yeah. And the other thing to think about here is that Jamie's interested in a color model.
Yes.
So whatever process you go through, it has to preserve the color map that they're getting off of Google.
Let's talk about that a little bit. If you're using a multi-materials approach, then the objects have to be retained as separate objects, and you have to address them differently in your slicer. However, if he's using a multi-jet, I believe
it's
multi-jet, multi-jet as with the original. I forgot the name of the company when it was Gypsum. Z-Core. Yeah, that you don't get your colors through separate objects. You get your colors as the map.
As a color map.
Yeah, and that gets placed on top of the mesh, the object, as a kind of a mapping. That's what 3D Coat does.
Right.
And perhaps in 3D Coat you can get that color map and paint, but I've never done it, so I don't know how to do it.
Yeah, I don't have much experience working with color maps like that. But I'm assuming that you're getting that color map from Google, and the idea is to preserve that into a 3D.
Yeah, so your size and locations are critical. So I would chop it up into smaller chunks.
Mm-hmm. What is smaller? Smaller chunks.
Smaller chunks, but enlarged.
Okay.
Smaller bits of the map, but they have to be enlarged. And I want them enlarged so that you can deal with finding the errors, see the errors.
But that basically relies on you to fix the errors manually then. And the problem is that we have an impractical number of errors to fix manually.
Yeah.
I mean, if you wanted to fix them manually, that's an easy enough thing to do. It's just,
for sure, it's an extremely long-term project. Yeah. It's not something that can be done wham bam and print. Forget that.
And the problem is you also have to make sure that you are preserving your color maps. So if you're remapping the topology of the model, you're going to have to change the topology of the color map in some intelligent way to meet that.
As long as all of the objects, the individual meshes, which hopefully you've made manifold, retain their size and location correctly, that's not a problem.
Well, but the problem is that you're taking 1,000 objects with 1,000 separate color maps.
That's why I say chop it up. Chop it up into smaller chunks.
Okay, but even if you've got 100, it doesn't matter. The problem is the same. You've got we have a square of lawn, and we have your house on it, right? The lawn has a color map. Your house has a color map. Neither of them is manifold, right? So we've got to make them both manifold objects and merge them together in some process. Either we merge them together first, which would be kind of difficult, or make them both as manifold objects and then Boolean them together. But in doing so, we also have to take the color maps and make them make sense on the new object.
Right. So you need to merge the color maps as well.
Right, but it's not just merging the color maps, because parts of the color map are going to map differently because you've changed the topology of the object.
Or you leave the topology of the object the way it was and just print it.
But then you've got 1,000 separate objects on top of one ground, which maybe their software can handle. I don't know. I've never printed on a multi-jet myself, so I don't know how picky they are.
We're making an assumption that the final product is a small, as if you're in an airplane looking down, and again, when you're starting to scale objects and you're zooming them into small objects, doesn't matter what the object is, you're going to have a lot of issues. There's no way around that.
Yeah.
And that's the iconic issue of scale with 3D printing. I mean, it's like I've had architects come to me with their models. Can you 3D print this for me? And I go, well, those benches aren't going to resolve very well. Those little benches,
they're just too small.
You want this 70-story building with benches in a park on the bottom.
Right.
Those benches aren't going to work out. Those rails along the patios, they're not going to print because
they're just going to make garbage on your model.
Yeah, and you're going to have that kind of issue with this use case as well.
Sure. Yeah.
There's no way around though. There's no way around to do that.
Right. Yeah,
the way to get around that is you design the object at that scale to begin with.
Sure.
And you'll be fine.
Yeah, that makes sense. Anyway, interesting question, and thank you, Jamie. Good luck with it.
Yeah, let us know what happened.
Let us know if you come up with something.
But I believe the best starting approach is, chop it up into smaller chunks, not
sure.
physically smaller, but smaller areas, and makes it much more manageable.
I would say take one building on one square of ground and figure out your workflow and then go from there.
Yeah.
But even the workflow to do one of them is, I'm sure somebody can do it, but I can't think of a way offhand.
Mm-hmm. Oh boy, Whitney, a new show written to the hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, thank you all out there for your support on Patreon. Thank you for your positive reviews wherever reviews can be made. And hey, thanks for listening. We do it for you. We do it for fun. We don't really do this for money or fame. We have a tiny audience. We have a very curated audience. Only the most refined, well-heeled 3D printing nerds listen to our show.
I prefer to think of it as exclusive.
Only the most intelligent.
We have an exclusive clientele.
Yes. I have a thing. Oh, actually, it's your thing of the week.
My thing of the week. Yes. Yeah. I was doing my usual peruse through all of the things for the last couple of weeks in the Thingiverse, and I found this is a little bit hard because the actual title in Thingiverse is in Cyrillic.
Yeah, but we translated it for everyone.
Yeah, so the translation is Periscope Ukraine 2022, and this comes to us from make sure I get his name right, Kal King. He was from the Ukraine, and his actual name is Petro Yesip. And this is very clever, and I hope this is not useful in your part of the world, but if it was, this would be a good thing to have.
Yes.
It's a periscope that you basically have two 3D printed ends and then a section of just PVC pipe in the middle. And then it's very clever design that uses rubber bands or zip ties to hold mirrors in place. And you can hold mirrors or looks like maybe, I guess that's a mirror rather than a cell phone that he's got on it. But you could potentially attach a cell phone to it, perhaps. So anyway, very clever, very quick way to produce this. And I hope any of our listeners in the Ukraine are safe and don't require a periscope to see what's going on outside their window. But in case you do, it's good to know that this is available.
I would bet that at this point in time, it's probably not likely that folks in the Ukraine will be able to get the feed. Because the internet's probably down. I know that Elon Musk sent a pile of equipment and opened up services from his satellite system for key people to get information in and out of Ukraine. Mm-hmm. But I really doubt that most of the people there would even have the time to sit and listen to a podcast or anything else of any value beyond here's how to get out of there, or here's what to be safe.
Here's what you need to be safe.
But I got to say, this is an ideal thing of the week, and I wish we could be churning these out and sending them over there with the pipes and the mirrors, because let's face it, when you're in a situation in urban warfare, you stick your head out, you can get killed.
Yep.
So good luck to the folks out there.
Anyways,
and this is an interesting thing to make as it is.
So thing number is 526. 6453, and even if you don't have a need for a urban warfare periscope, go put a like on it or collect it or whatever, just to show some support for the guy.
Good idea. Great idea. It's on thingiverse.com. If you've got a tip, a question, or a comment, please send us an email.
Send it to info@3dprintingtoday.com. That's THREE followed by the letter D, printingtoday.com.
Let's see, we do have a show next week. Show number 424. When we start out talking about Monocore Clear resin, we do a review of it.
Let's see. Then we ask, should we build a Voron?
Should we build a Voron? I know a lot of people out there going, yeah, what are you waiting for? And then you tell us about...
Build the Voron, you moron.
Build the Voron. And then we...
Don't be a moron, build a Voron.
Then we debate different key hanging projects. Key hangers. Those are really important.
Yep.
I guess that's it.
All right. Thanks for listening.